This video is an introduction to probability. By the end of this video, you should be able to define probability, sample space, event, trial, outcome, independent, and random. You should also be able to describe the law of large numbers and know the 5 principles of formal probability. First, let's discuss some vocabulary. My definition for probability is how likely it is for an event to occur. The sample space is all possible outcomes. So with the example of rolling 2 dice, the sample space would be the numbers 2 through 12, because that is the set of all possible outcomes. An event is a set of outcomes to which a probability is assigned. So for example, I could look at the event of rolling a 7. Okay? Now there are several things that could happen to get a 7. I could get a 1 and a 6, or a 3 and a 4. But the set of outcomes to which I assign that probability, that's the event of rolling a 7. A trial is one occurrence of a random event. So rolling the dice once would be a trial. And the outcome would be the result from that trial or that occurrence. Okay? So if I rolled the dice and I got a 4, I got a 2 and a 2, that's a 4, that would be the outcome of that trial. Okay? Independent is also a really important word when it comes to probability. And my definition for independent is the result of 2 occurrences don't affect each other. So I pick up my 2 dice and I roll them, and then pick them up and roll them again. Those 2 trials are independent of each other because what I rolled the first time does not affect what I will get the next time. Okay? And also, finally, a definition for random is that no one knows the outcome until it happens. So when I want to roll a dice, I don't know what I'll get until I actually roll them. Okay? That's why it's random. Next, the law of large numbers. The law of large numbers is an idea that you may have understood intuitively, but didn't have a name for. And I'm going to use the example of flipping a coin to explain the law of large numbers. When flipping a coin, we expect to get heads about 50% of the time. Okay? And so I used an online simulator to simulate flipping coins, sets of 10 coins. Okay? This may not surprise you that I got 5 heads or 4 heads or 7 heads, that it was different almost every time how many heads I got. Okay? And this is because I'm looking at a small set of numbers. 10 flips is relatively small when compared to all possible, number of flips. Okay? The law of large numbers is the idea that the long run relative frequency will get closer and closer to a single value. Okay? In this case, for flipping a coin, that value would be 0.5 or 1/2. Okay? So when I did it 1,000 times, it was much closer to 1/2, and when I did it for 4,000 times, it was even closer to 1/2. And I think it makes sense that if I did it 10,000 times or 20,000 times, my relative frequency would get very, very close to 0.5. Okay? Because this probability is developed by doing it over and over and over again, it's sometimes called empirical probability. Now that is different from theoretical probability. Theoretical probability is based on a mathematical model, not repeated trials. Okay, and it gives us this formula, which I'm guessing that you are pretty familiar with in finding the probability of an event. It's the number of outcomes in event A divided by the number of possible outcomes. So for example, the theoretical probability of drawing a face card is the number of face cards out of all possible cards, which is 12 over 52 or 3/13. Next, let's talk about 5 principles of formal probability. Some of these ideas you will be very familiar with, and some will be kind of new to you. Okay, the first is that a probability is a number between 0 and 1. Okay, the probability is 0 if the event will never occur, and it is 1 if the event will always occur. Okay, if there's a low chance of it occurring, it has a low probability, a number closer to 0. If the probability is high, meaning closer to 1, then there's a high chance that it would occur. Okay. Number 2, the set of all possible outcomes of a trial must have a probability of 1. Okay, now this is called the sample space. So the probability for the sample space to occur, or something in the sample space to occur would be 1. Okay, so for example, if I'm flipping a coin, the probability of flipping a heads or a tails, that's the only possible outcomes, would be 1. Or rolling a number 1 through 6 on one dice would be 1. Number 3, the probability of an event occurring is 1 minus the probability that it doesn't occur. Okay, and the probability that an event A doesn't occur is called the complement of A and is written with a superscript C. Okay, so for example, the probability of flipping a heads is 1 minus the probability of not flipping a heads. Okay, the probability of not rolling a 2 on a dice is 1 minus the probability of rolling a 2 on a dice. Okay, this is very useful to us when we are trying to find the probability of an event that is kind of difficult to figure out. There's lots of different cases, but the complement might be very easy. Okay, for example, down here, this last example, the probability that not all students ate lunch is equal to 1 minus the probability that all students ate lunch. It's often very easy for us to look at cases where all students ate lunch, or all the coin flips were heads. We're dealing with everything. It's much easier for us than dealing with some of them. Okay, so oftentimes the complement is a very useful tool for us when finding probabilities. Number 4, for 2 disjoint events or mutually exclusive events, meaning that they are totally separate, the probability that one or the other occurs is the sum of the probabilities of the 2 events. Okay, so the probability of rolling a 1 or a 4 on a dice, those are separate events. They can't happen at the same time. You can't roll both a 1 and a 4 on one dice. So that probability of rolling a 1 or a 4 is equal to the probability of rolling a 1 plus the probability of rolling a 4. Okay, or picking out one M&M, and the probability of picking out a blue or green M&M is equal to the probability of pulling out a blue plus probability of picking out a green M&M, because those are disjoint events. They can't happen at the same time. Okay, what if the events aren't disjoint? Okay, we'll talk about that in the next chapter. There's a general addition formula that we deal with in that case, which actually is a more common case. Okay, number 5. For 2 independent events, A and B, the probability that both A and B occur is the product of the probabilities of the 2 events. Okay, so probability of A and B happening is A times B. And by the way, this symbol right here is called the intersection. Okay, and I should have mentioned that back here, this symbol is the union. Okay, but the probability of rolling 2 1s on 2 dice, rolling 2 dice and getting both 1s, is the probability of rolling a 1 times the probability of rolling a 1. Those are independent events. What I get on one dice won't affect the other one. And finding that they're both 1s is probability of rolling 1 multiplied by itself. Okay, or drawing 2 cards, but with replacement. So I draw 1 card, I put it back, I reshuffle, pull a second card. The probability of pulling up a heads and then a diamond would be the probability of picking up a heads times the probability of picking up a diamond. Finally, I just wanted to give you some good rules of thumb when working with probability, and those are when in dealing with situations that have or, this or that, you generally add. In situations with and, meaning this and that both occurring, you generally multiply. And finally, situations that with not this, is generally 1 minus that thing happening. Those are some really good rules of thumb when working with probability. This video was an introduction to some ideas of probability, both some important terms, the law of large numbers, which is a really important idea, and also 5 principles of formal probability. Thank you for watching.